Hello everyone, welcome back. In this third part of MCQ questions on signals and system, we'll be dealing with five questions related to energy and power signal. So without any delay, we'll start with the first question. The first question is the continuous time signal x of t is equal to e power minus a mod t is option A energy signal, option B power signal, option C neither energy nor power signal, and option D both energy and power signal. This is a very simple question. In order to answer this question, you should know that any periodic signal you take, it is actually power. Okay, if it is a non-periodic signal, basically it's an energy. Again, we cannot just directly conclude that it's an energy. We'll have to do some mathematics, but still, in a vague way, we can say that if it is a non-periodic signal, it is actually energy signal. Depending upon the option, you have to decide how to approach the problem. Okay, so trick here is P and P. Okay, if it is a periodic signal, it's a power signal. If it's a non-periodic signal, it's a energy signal. Okay, now whether this is periodic or not is the question. Okay, so as we discussed in part 1 of the lecture, x of t is equal to e power minus a mod t. Mathematically, it is defined by it is an exponentially decreasing signal minus at for t greater than 0, and it is a exponentially decreasing signal plus at for t less than 0. So graphically, this is how it looks like. For positive values of t, it is exponentially decreasing. For negative value of t, it is exponentially increasing. Right? Now, this signal is periodic. How do we define a periodic signal? A periodic signal is said to be one which repeats itself after a particular time interval. Is this repeating itself after a particular time interval? No. It is basically a exponentially decreasing and exponentially increasing signal. Since this is not a periodic signal, therefore the option is A. It's a energy signal. Let us look at the second question. Second question is the signal x of t is equal to A times sine t is option A energy signal, option B power signal, option C neither energy nor power signal, option D both energy and power signal. As we discussed in question 1, if the signal is periodic, then it's a power signal. If it is non-periodic, mostly it will be a energy signal, right? Now A into sine t is a periodic signal, no? So sine wave, don't worry what is the frequency, but it is a sine wave. All sine waves are periodic, right? So it's a power signal. And the answer is B. So A into sine t is a power signal. Now we shall look at the third question. Third question says energy of a continuous time signal x of t is equal to RECT of t by t naught is option A 1 joule, option B 10 joule, option C pi by 2 joule, option D t naught joule. So what is the equation to find the energy of a signal? It's easy. Given a signal, you square the signal and integrate it for that signal duration, time duration. Okay, so let me write the formula first. Energy of a continuous time signal is given by integrating from minus infinity to infinity x square of t dt. Square the signal and integrate with respect to the duration what we have in our given signal. So in order to integrate it, we should know what is the signal. As we discussed in, I guess, part 1 of the video, how does RECT of t by t naught sequence looks like? It's basically a rectangular pulse, as name itself says RECT. Graphically, this is how it looks like. It is varying from minus t naught by 2 to t naught by 2. Its amplitude is 1. Okay, if I had something A here, A into RECT of t by t naught, then the amplitude will be A. Since it is just 1, so here the amplitude is 1. Now I have to integrate this signal, which is x of t. First I have to square it and then integrate it from minus t naught by 2 to t naught by 2. We'll do that. It's simple. E is equal to integrating from where to where? Minus t naught by 2 to t naught by 2 minus t naught by 2 to t naught by 2 x square of t. What is the amplitude of the signal x of t for t varying from minus t by 2 to t by 2? Its amplitude is 1. So its square, so 1 square is 1, 1 into dt. Now integration, differentiation cancels out. I end up with t with just a limit minus t naught by 2 to t naught by 2, and this is equal to upper limit minus lower limit. Upper limit is t naught by 2 minus of minus lower limit plus t naught by 2, and this is equal to 2 times t naught by 2. 2 cancels out, so it is t naught joules. Okay, answer is D, t naught joules. Now we will look at question number 4. Question number 4 says a signal is called as energy signal if and only if its energy is finite, its energy is zero, its energy is infinite, and none of the above. So in order to answer this question, you should note few points on energy and power signal. Let me write it down. It would be better if you know these 4 to 5 points, then you could answer like some of the questions based on energy and power signal. Okay, so I'll make it as note. Note number 1: a signal is referred to as referred to as energy signal if and only if the total energy of the given signal is finite. Okay, a signal is referred to as energy signal if and only if the total energy of the signal is finite. If the total energy of the signal is finite, then we call it as energy signal. Similarly, point number 2: a signal is referred to as power signal if and only if the average power, not the total. When we say energy, it is actually total energy. When we say power, it is not the total power, it is average power. The average power of the signal is finite. Okay, so a signal is referred to as power signal if its average power is finite. Mathematically, its energy should be in between 0 and infinity, and its average power should be in between 0 and infinity. Now point number 3: energy signal has zero average power. Energy signal has zero average power, and power signal has infinite energy. So energy signal has zero average power and power signal has infinite energy. Okay, this is point number 3. And point number 4, I'll write it here. Point number 4. Point number 4 says that a signal cannot be both energy and power signal. Signal cannot be both energy and power signal. And the last point, and this point we discussed in question number 1 and question number 2, periodic and even random signal. Periodic and random signals are usually viewed as power signal, and deterministic and non-periodic signal is viewed as energy signal. So these 5 points you should note. If you know this point, you could answer few questions based on energy and power signal. Let me repeat all these 5 points in a short. A signal is said to be energy signal if its total energy is finite. A signal is said to be power signal if its average power is finite. A signal has zero average power and power signal has infinite energy. And 4th point is a signal cannot be both energy and power signal. And 5th point says that all periodic signals are power signal, all non-periodic signals are energy signal. Okay, so with these points in our mind, what is the answer for this question? A signal, let me delete this. A signal is called as energy signal if and only if its energy is finite. So therefore, option is A, its energy is finite. The signal is said to be energy signal if its energy is finite. In the sense, E should be in between 0 and infinity. Now we will look at the 5th question. 5th question says that a signal is said to be power signal if and only if its power is finite, its power is infinite, its power is 0, and none of the above. So as we discussed in question number 4, what was the second point? Second point was a signal is referred to as power signal if and only if its average power is finite. So answer is its power is finite. So this is the nearest options I get as a solution to this problem.